All right, let's get a precipitation reaction now. And a precipitation reaction means we're mixing two liquids together, and then a solid comes out of solution. That solid is called the precipitate. So we'll learn how to predict whether something is going to come out of a solution in a further lecture, but let's first look at what a typical precipitation reaction might look like. So if we look at this chemical equation here, we see the states of matter on this side are both aqueous, and remember aqueous means dissolved in water. So we have this potassium chromate dissolved in water, this barium nitrate dissolved in water, and then what's produced is we still have potassium nitrate in aqueous solution, but we have a solid, a barium chromate solid coming out of solution. So if something's aqueous, that means it's dissolved in water. And when you have an ionic compound like this, what we really have in this solution is we have two K plus ions, potassium ions, and then we have this chromate in solution, and then we also have a barium cation that's aqueous, and two nitrate ions that are aqueous. And then that's going to form, sorry, getting my pens mixed up. It's going to form two potassium that are aqueous plus two nitrite ions. And then we have this Ba CrO4 that's going to be a solid. All right. And so that's what we would have floating around inside of our mixture there. Before we mix them together, we'd have a solution that had these potassium cations and these chromate anions. We'd mix it with these barium cations and these nitrate anions. So this is an example of what we call a double displacement reaction. And in a double displacement reaction, the two partners switch places. So here, the potassium cations are with the chromate, and on this side of the equation, now the potassium is with the nitrate. Here, the barium cation was with the nitrate, and now the barium is with the the chromate. So we've kind of taken this cation, and it's now with that anion, and this cation is now with this anion. So the two partners have switched and they've formed different things. One other thing we can see from this precipitation reaction is something called a spectator ion, right? And so in a chemical reaction, new compounds are formed. So if we look at this reaction, on this side of our arrow, we have these potassium that are still aqueous and these potassium cations. So they're not taking part in the chemical reaction, they're just spectating. Also we have these nitrate, and these nitrate are the same on both sides of the arrow, so they're not really taking place in the reaction, and they would be called spectator ions. So the real thing that's going on here is we have this barium 2 plus aqueous, and we're adding it to CrO4 2 minus aqueous, and what's produced is this barium chromate solid. And so this is your precipitate, is the solid that is coming out of solution. So again, this is also called a double displacement reaction because the two partners are switching. Here the potassium was with the chromate, now it's with the nitrate on this side. Here the barium was with the nitrate, now it's with the chromate. So they're switching, so it's a precipitation reaction. But it could also be called a double displacement reaction. And these anions in here, like the potassium cation and the nitrate anions that are the same on both sides of the equation, aren't taking part in the chemical reaction, so we call those spectator ions. So we could write this net ionic equation that just shows what is actually going on, or this cation and this anion are coming together to form this solid.